Welcome to wasmCloud community meeting for January 27th, 2021, where we're trying to enable developers to build their services in WebAssembly and run them everywhere. We've got a couple new members this week. John Mark Walker, you want to do an intro?
Greetings. Yeah, I run the open source program office at Capital One. I am a new convert to wasmCloud, so I look forward to seeing what we can do with it.
Awesome, and thank you. And we've gotten into a tradition of starting off our calls with a demo. And this week we actually have two demonstrations. Microsoft will be doing an update of the Krustlet demo, but they're unable to start until 1:30. So Brooks is going to get us started with a demo. Brooks, I'll hand it off to you.
All right, sounds great. I might also need to be co-host so that I can share my screen.
Yes, hold on just a moment.
So while Liam's getting that ready, yeah, I'm Brooks Townsend. I believe I met most of you on here, but I work at Capital One with Kevin on the wasmCloud team. Been doing this for a few months. There we go, I got it. So what I'm going to be showing you today is the Polyglot actor experience with wasmCloud. So how wasmCloud supports Polyglot actors and how our use of WDL and our generic actor interfaces define the contract that actors and providers can communicate on, regardless of how or what language you actually write your actors in. So to get us started, I'm going to share my screen. You should be able to see a pretty blank Visual Studio Code window now. So let me know if you can't see it. But I'm going to start us off with a little bit of a business app proposition. So for this business app, what we want to be able to do is write a program that can increment a value in a key value database as a response to an HTTP request. Pretty simple idea, but what this does involve is interacting with a key value database and acting as an HTTP server. So writing this outside of wasmCloud, say in like Java or Go, for example, you're going to be bringing in all this shared library code and working with language-specific libraries and lots of boilerplate code just to get to writing your actual business logic. So I'd like to show you how we tackle that with wasmCloud, starting with our interfaces. So we write our interfaces using the WebAssembly interface definition language, short for WDL. If you would like to learn more about WDL or what we're doing with it, our last community meeting last week had a demo hosted by Phil Ketty, which was awesome, showing off the WAPC CLI and the WDL as a spec. So definitely recommend checking that out on YouTube if you haven't seen it yet. But for this demo, what we're doing with these interfaces is specific to our KV counter actor. We need to define what it looks like to be an HTTP server. So this WDL is fairly simple. We're defining an interface with a single function called handle request that takes in a request and gives back a response, just like a pretty regular HTTP server. And we're defining those request and response types here.
Next, one of the interesting things to point out here about this contract is the contract is a business level contract. So it doesn't contain any information about how the HTTP request comes in, doesn't contain anything about port opening or threading or any of those other things. It's purely an abstraction around the business idea of responding to web requests.
Exactly. Yeah. Thank you, Kevin. And you can also see that illustrated here with our key value contract. Looking at this, if you've interacted with a key value database before, these things will all look familiar. Generic operations for getting keys and retrieving a value out of a database, adding a number or adding a value to a certain key in a database. These are just abstractions around what a key value interaction is supposed to look like. And this is what we need to write as our generic interface. Now that we have that generic interface, I mentioned the WAPC command line interface. We can directly from this WDL generate language-specific interfaces for our actors to use. So I've already gone through the process of doing this to spare a little bit of time for the demo, But taking a look at the Rust HTTP server interface, this is all of the code that's generated for us using the WAPC tool. So the WAPC command line tool. So you can see some pre-generated structure for a capability provider host on a certain binding. The important part here is the single function handle request, which is what we defined in our interface, which takes in a generic HTTP request, returns a response, and the structures for a request and response types. So you can kind of see the API being formed here for Rust actor to be able to interact with these generic types. Same thing with key value, but we can, like I said, we're generating these language specific. So I'd like to show you the HTTP server generated version while it's fresh on your mind for AssemblyScript. So for AssemblyScript, we're going to see largely the same structure, a host class over a certain binding with a single function called handle request. And if we scroll down a little bit, all of this is pre-generated, so the extra glue that's binding all this together is not something you need to worry about. We have a HTTP response class for in a TypeScript module, and a, oh, I passed it, and an HTTP request class. So all of this was automatically generated from a single command from those WDLs, the interfaces that we wrote. And this is how actors are going to be interacting with these resources through these abstract interfaces. Saw something in the chat. I'm just going to make sure it's not anything crazy. Yeah, thanks, Liam.
Yeah, I was just going to paste into from last week. It's in the notes and the documentation for using the CLI to do these two generations from your WDLs here. The first command to type in would be, something like the CLI new assembly script hello world, right, Brooks? And then once you've edited your WDL, then you can use make in order to generate your, actually compile your WDL into your interface. Is that, Brooks, did I get that right?
Exactly. Yep. And that was shown off really well last week in the community call. Definitely recommend checking that one out, because all the generated code that I just showed you is only output from that WAPC new AssemblyScript HTTP server and then running make. So from here, it was all generated from this interface that we've written here for HTTP. I'd like to show you, so both these Rust and AssemblyScript actors are going to be interacting with the same common interface with their own language specific things that have been generated for you. Now, this team that's trying to implement this business app, so this KV counter app, have two competing developers. One loves Rust because they've been working with it for a while and they like some of the aspects of the borrow checker. And one's going to be working with AssemblyScript because they are completely convinced that the smaller binary for AssemblyScript way outweighs the benefit of any other language. And so these two competing coworkers are going to write their own KV counter actor, and we'll see what that looks like. So opening up the actor KV counter for Rust, this is the entire program. So we import a couple of libraries, including our generic HTTP server interface and the generic key value interface. We have a single function called WAPC init up here, which is our the entirety of our boilerplate here to register a health request, which is used internally for the host. And most importantly, in the HTTP module, register a function that's going to handle HTTP requests. So this function is increment counter. It takes in a request and returns a response. All it does here is takes the path of the request, and it's going to add 1 to that value in a key value database. Notice here in this actor, as we're writing this, we have no idea how this HTTP request is going to get here, where the response is going afterwards. More notably, what type of key value database we're even going to interact with here. This default function is instantiating it on the default binding, which is almost just like a namespace in Kubernetes. But we don't know if it's going to be Redis or Cassandra or maybe even an in-memory key value on the other end. So this is what an implementation may look like with Rust. With AssemblyScript, we can see here a decent amount more color from the Visual Studio Code highlighter, but mostly the same. Some shared types from the actor HTTP server interface, a WAPC init function to register your handlers, and then a handle request function that takes in a request, sends back a response that initiates or instantiates a key value host and adds one to that key. So what's completely absent from both of these is language specific boilerplate code for interacting with HTTP servers or key value databases.
Yeah, basically the main reason why there's about 10 more lines of code in the AssemblyScript one than there is in the Rust one is that AssemblyScript doesn't have some of the fancier JSON macros. So we have to construct our JSON object by hand here.
Yeah. Even then, with all that stuff, I mean, this is maybe 10 lines of code to do all of this. So the key thing here, both of these actors are interacting with the same common interface generated from that WDL definition that we came up with. So now I'd like to show you what this looks like in action running with wasmCloud. So I'm going to open up my terminal. We're going to use the wash command line tool and the up command to launch an interactive REPL for wasmCloud. What this does is launches a host that we're free to interact with directly in this REPL. And we can see, I gotta do a fun tmux thing. We can take a look at this host's inventory and see that we have 2 providers running in it currently, which are core to just wasmCloud running its core program. So we can start by scheduling our Rust KV counter actor, which we have uploaded into our, God, it is hard to type and talk at the same time. We have uploaded into our Azure Container Registry, which is an OCI compliant registry, and it's where we host all of our artifacts. And we can also host or schedule our AssemblyScript actor into this same host. We're not specifying what host this is because we only have one running, and it's going to respond to the auction of, hey, I'd like to schedule this actor. So we can see those 2 actors are running. The next step is going to be scheduling our capability providers, which is the thing at the other end of the interface that's actually going to be implementing this part. Or implementing the functionality. So actors will always interact with a key value abstraction. For example, Redis is going to be the provider on the other end of the black box that is actually going to interact with the database and retrieve values for you. Now that we have those actors and providers scheduled, the only other thing that we have to do is link the providers and the actors together. So what this does just connects them over a certain contract so that they can interact over that contract and start making code happen. So we can do that by running link with, we'll start with the KV counter actor public key, the Redis public key over the contract wasmCloud key value. And this connects to Redis over, can't see, over localhost 6379. I have it running in the background, already done for this demo. And then we can also link the Rust KV counter actor to the HTTP server provider over our wasmCloud HTTP server contract. And we'll schedule this, or we'll have this listening on port 8080. Now I'm going to do the same thing for the AssemblyScript actor, just link it exactly the same to Redis and to HTTP server. The only difference is I'm going to put the AssemblyScript actor on port 8081 just so that we can have a little bit of difference. And that's it. So all of our actors and providers are running in this host, and we have linked them together so that the provider can appropriately talk to Redis, and they can appropriately interface over this contract ID. Now let's see what this looks like. So if we curl localhost at 8080, which will be our Rust key value actor, is sitting on the other end of this link to HTTP server. And we'll do something cool like Wasm community demo, and we'll see what value is in that database. Since we haven't queried that before, it's going to add 1 to a non-existent key and return 1. So this is entirely what it looks like for an actor to receive that HTTP request, increment that counter, and send it back over the wire. Now, the cool thing here, if we swap out this port to 8081, we're now going to be talking to an AssemblyScript actor. Doing that, you notice that the count continues to increment as it was before, and that's because it's linked exactly the same to the Redis provider and HTTP server provider. You can only really tell that it's different from the fact that our payload is slightly different. From Rust, we set up a payload of counter, and from AssemblyScript, we do it of count so that you can actually see a difference. So at the end of, or through this curl, really, there's a couple of awesome things that are happening. First of all, it makes no difference to the end user what language you actually wrote your AssemblyScript actor in. So of course, that's what you want from any program. No end user should really care what language is like implementing that functionality under the hood. What this means with our generic interfaces is from the provider perspective. So when we write a Redis provider over the wasmCloud key value interface, we don't need to care what language the actor is going to be coded in. As long as it implements that common interface and communicates with it, that's all we care about. And the impact for the developer here is these two developers on this team that wrote this AssemblyScript and Rust actor, they're both free to use whatever language they want, because as I've been hammering in, as long as we're communicating over this common interface, the language is completely arbitrary. As long as it can use that interface and compile to WebAssembly, then it's perfectly fine as a wasmCloud actor.
Yeah, and because these things are wasmCloud actors and they're WebAssembly modules, any of the actors that you write in any of these languages, they don't take a direct dependency on a web server. They don't take dependencies on Redis or Cassandra or any other non-functional requirement. They have these things are truly freestanding with no external dependencies.
Exactly. If we decided to use, if I do this demo next week with a Cassandra provider, I won't have to change this actor for either language at all.
I'd point out that this is, from the enterprise perspective where, you're running fleets of thousands of applications. This is one of the biggest uplifts in the life cycle of this app. When you have those dependencies baked into your apps, you also are baking in their management. So let's say that there was some Redis library or Cassandra library baked into this. When there's vulnerabilities or updates or anything along those lines, it requires compilation, recompilation, and recreation of artifacts and redeployment. So we're decoupling the lifecycle and management via these generic actor interfaces. That is, from a fleet perspective, is one of the biggest crises in enterprise development today.
Yeah, does anybody have any questions or want me to show a little bit more code here? Happy to poke around. I guess there's not that much more code to show.
I know you've demoed this before, but I would love to see this again. And I'm sure there's probably a couple people on who haven't seen it, but can you show using the REPL to make those invocations directly without using curl?
Sure. Let me just grab exactly what I need there. So all you need to do here is we can use the call command to directly to directly invoke one of these things. So when you curl one of these actors, it invokes the HTTP handle request function. And then that carries out actually returning the response to you. We can directly call this actor at its handle request function and directly get a response back without actually having to curl. So this just looks like running cuddle call with the public key, and then the invoking the handle request function. And relevant to the demo, we provide a complete JSON payload of an HTTP request. So what was my key here? Wasm community meeting, Wasm community demo. So if we call this actor's handle request handler, let's see, that should show up there. Kevin, I almost got through a demo without something going wrong.
Yeah, this time it's absolutely my fault for asking you to do this too.
Mm-hmm. Is that the right one? That is the right one. Let's try the AssemblyScript actor. It is actually possible that I have this payload copy from an old version of the interface. So
it looks like the interface is having a parse problem. It's not making it to the actor, so it's washed the setting the issue.
I actually know exactly what it is. In the REPL, this little single quote will throw it off. Darn. All right. It will throw it off, but there it is. So the payload can't be surrounded in single quotes in the REPL, but calling this directly, we get this raw JSON payload back because we're serializing with message pack. And so it looks kind of corrupted in the beginning, but the body is still serialized the same.
So this has a huge impact on developer productivity and being able to test your own stuff, because when we're trying to do cloud microservices and lambdas and all that stuff, being able to poke and prod the business logic in the absence of all those non-functional requirements is usually impossible. It's super hard to do with AWS, with Lambda. It's even hard to do for making, microservices with Go and whatnot. But here, you can poke and prod any actor independent of the provider that would normally do it for you.
Yeah, we can actually stop the HTTP server provider entirely and just directly interface with this actor.
I think that's an understated point right there for testing and things like that. Brooks, this has been a really awesome demo. We've been kind of working towards this vision for such a long time. It's kind of wild to see it, all working in different languages simultaneously. Does anyone else have any questions or things they want to dare Brooks to do? I think we're at the double dog dare at this point. If anybody wants to violate protocol and move right to the triple dog dare, I think that's acceptable in this context. All right, Brooks, solid demo, man. Thank you. That was a great one.
Yeah. Thanks
so let me just share my screen. We'll get back on the agenda here because I know we've got another demo today. Some quick community activity. I want to make sure that everybody's aware around two events. The first is the Cloud Native Wasm Day that's being put on by the CNCF as a part of and building up towards KubeCon EU. The call for papers is open, and the intention is to pull together anyone and any effort that is really around the intersection of WebAssembly and cloud native computing. So Andrew Brown, I would really encourage you guys to submit a WASYNN. I think it'd be a great place to demo what you guys are working on. Microsoft team, obviously, Krustlet, Bindle, all the things, and wasmCloud team as well, as far as getting some events up there and out. And then there is another, there is shortly before that, this is on May the 4th. So hopefully we'll see some Baby Yoda branding. May the 4th be with you. And there's another WebAssembly Summit that's currently being planned for April 22nd. And I apologize, the CFP for this one has already closed. But I'm really looking forward to this one as well. I have been told just for planning that the KubeCon EU event will be an online only event, but already thinking ahead towards the end of the year that the KubeCon US event will have both an online and an in-person component in Los Angeles this year. So just looking ahead to planning for the future. Are there, let's see, the Wasm Time, other community events? The regularly scheduled Wasm Time call is next week on Thursdays at 4. Are there any other community events that people should be made aware of?
There's the runtime working group. I don't have the specific details, but I can post it up there in this Google Doc.
Okay.
It's not Wasm Time related. It's just the CNCF WebAssembly Runtime Working Group.
Yeah, I'll make sure we get it linked in here for the notes when we post them, Kevin. I was just putting a note on for the Wasm Time meeting. With the demo from on Krustlet coming up, I think we've got Kevin from Microsoft that's supposed to join us.
Not from Microsoft.
Not from Microsoft.
No, he's just one of our fellow core maintainers on Krustlet.
Oh, okay. Well, look, Kevin, let me, we didn't actually offer you, you weren't here at the beginning of the meeting. I know you had a conflict. Let me make you a co-host here. And if you wouldn't mind making, maybe doing a quick introduction, and we'll let you turn over the demo for you.
Sure, sounds good. Let's see. Am I good to go? Cool. Yeah, so I'm Kevin. I've been working on the Krustlet project for, I guess, since May, April or something like that. And I mostly got involved. I'm not super involved in like the Wasm scene, but I got involved because I'm really passionate about Rust, and I've been working with Kubernetes a lot lately, and so that was kind of a good intersection there. And then I guess what we were planning to demo today was actually a new crate that we've split out of Krustlet called Krator. And earlier in the fall, we moved Krustlet to using a state machine model for sort of defining and then managing the pod states within the Krustlet. So Krustlet is a Kubernetes kubelet sort of replacement written in Rust that's still very beta. But essentially we wanted to improve the reliability of sort of managing pods as they move from like, being registered to pulling images to running and then eventually exiting. So we came up with a new state machine API for that. It got quite a bit of good reviews from people who have taken a look at it in the last couple of months. And so we decided to split that out into its own crate, which allows you to write sort of more generic operators using the state machine API in Rust. That was just sort of some of the community feedback we got, was that people were excited to write their own operators. And so I can share my screen and walk you a little bit through this. So this is our API documentation. We haven't actually published the crate yet, so this isn't actually up on docs.rs yet. But essentially, there's an operator trait that you implement, and you have to define a number of types. Primarily the sort of Kubernetes resource type, and we leverage the K8S Open API types here so that you should just be able to use those right out of the box. And then you can define your own types for sort of describing like the status, and that gets posted automatically to you for you to the Kubernetes API. And then there's some types for managing the state of your objects internally. And then from there you supply an initial state and a deleted state. So the initial state is what it starts the state machine with, and then the deleted state is used if the object is marked as deleted in the Kubernetes API. It'll automatically transition to that state, and that lets you garbage collect and stuff before shutting down. So to implement a state, there's really just two methods. One is status, which allows you to produce a JSON patch, which gets sent to the Kubernetes API. And then the other one is the actual state handler, which is like an async function that you can use to actually execute whatever's happening in that state, like pulling images or what have you. So that's kind of a high-level overview of the API. We have a blog post surrounding the initial introduction of the API to Krustlet. That was back in September. And then there's another blog post that's coming out shortly that sort of describes this new crate and the API specifically there. But the focus of that blog post is a example I wrote, which leverages cube.rs's really nice derive macro for creating custom resources in Kubernetes. And I just kind of create a toy example that sort of like the custom resources like mooses. It's like kind of silly, but you can take a look and see. It's on our master branch right now. You can take a look and see at this example operator that's defined over this custom resource. So we implement a trait to wrap the status, and this is the state used for internally tracking things about the objects. And then I think there's 4 states that are actually implemented here. So like it registers a new object, and then the object transitions between like 2 or 3 states. And then there's the deleted state here where it releases the object. And there's an example of using shared state. So there's a type that allows you to have state that's attached to a particular object. And then we also provide some like concurrency behavior that allows you to share information between different objects that are being managed by the operator. So that's a pretty common ask. And then more recently, we merged in functionality that allows you to kind of easily detect when the objects are modified, and then you can transition to a new state to sort of handle reconciliation of whatever got modified. And then finally, I implement the operator trait, which I mentioned before. And then actually like launching the operator is pretty simple. I just initiate or create a kube config using cube.rs. And then this is sort of the main entry point, is this operator runtime, which just sort of blocks forever on the main task. So I can demo it. I've got some debug logging here that should show some interesting information. And then you can use cube.rs to automatically register the custom resource, but I've gone ahead and defined the YAML myself. So if I create that custom resource, let's see, -f. And I'm just running on kind here. Okay, so here I have no mooses have been created, but I can create an example. And you can see that like this is some debug logging. You don't necessarily have to have this on, but it tells you when it's entering various states and the status patches that it's applying. And then I have some logging that's actually coming from within the state handler. And then I mean, there's not much going on here other than you can see that the status phase and messages are getting updated as it transitions between the states. And then I can make things a little bit more interesting. I've created a script to just like generate multiple objects for it to track. And of course, I am not in the right conda environment. This is fine. So if I do something like that, it'll create a bunch more, and each of them gets their own state machine. They operate independently. It's all async. And so I'm pretty excited about this API. I think it makes it really easy to kind of think about how your operator is going to work, and think about concurrency between objects. And you know, the state handlers, we've purposefully made them infallible. They don't necessarily, they don't return like error types. So the intent is that you would explicitly define an error state, which would of course properly update the Kubernetes API with information about what error is occurring, and then maybe, you know, after some sort of error back off, you would retry the object, transition back to a registered state or something. And so that's kind of the pattern that we're favoring, is sort of that explicit error handling within the reconciliation loop. Any questions?
Kevin, would you mind pulling up the GitHub real quick? I just wanted to make sure I got that in the notes, just where you guys were on this.
Sure. Yeah, it's a subcrate in the main Krustlet tree right now. We're actually splitting out some of the providers soon, but I think this will stay in tree for a while.
Okay. Super. I'll make sure that's linked in the notes.
Cool.
This was a really awesome demo. Anyone else have any questions for Kevin? Krator is an excellent name, by the way.
Yeah, well, I think we're starting to to stress our convention of picking out random acronyms from 50 different words, but I thought it was pretty clever.
Yeah, I loved some of the early concept stuff for a walk still. You know, WebAssembly on Kubernetes, or you know, anything along those lines. I think it's important to try to bring like joy and fun into your work as much as possible. But thank you so much for attending today, and we'll also make sure to drop you a Slack invite in case you want to come and hang out on Slack with us or anything. We really appreciate the demo.
Great.
Super. And I'll make sure the details are linked into the notes there. A couple of other items coming up. Just a quick check-in. Kevin has been slaying away on docs. I know he's really looking for some review and some feedback. If you look on our GitHub, you'll see that there are a number of, you know, requests for review and comments up there. And this is, you know, available on Netlify and all tied in as we continue to develop this live. So I would just put a general call out to anyone that wants to contribute there. Heading back over to where we are with current, I'd kind of just put a call out to, you know, core team for any asks here as we kind of look down. I feel like actor interfaces, Brooks, you've been really slaying away at some of this still. How's it going?
Yeah, it's going well. A lot of what you saw today with the key value counter for Rust and AssemblyScript involved creating the HTTP server and key value for or interfaces for both of those languages. So we're cranking away at these. This is a big unit of work left for our 15 release, since the Rust ones need to be updated, and any additional ones, like for TinyGo, for example, we don't have on the roadmap for getting in for the release. But if you're excited about using wasmCloud with Go, the issues are out there, and we're happy to help push you in the right direction.
And then Phil, I know you've got a pull request in here on sort of like a on a reorg of this particular repo. Is that correct? Or there's a branch here maybe that has a the code gen restructure. And I think if we just show people this, it made a ton of sense to me when I saw it for feedback. But now it's organized by, you know, like HTTP server, and then you'd see per language under here. Whereas in the current branch, we've got it organized by language and then by you know, by function. Phil, any comments on that, or anyone else have any perspective on what they like better?
I'm a big fan of the restructured way of doing it, so that you discover by the interface or by the contract first, and then below that you can pick the language that's appropriate. I think it's just going to be easier to find stuff that way.
Yeah, I agree with you very strongly on that, Kevin. Anyone else have any feedback on that? Taylor, anybody? What like, just at a glance, what makes sense to you? Taylor dropped. All right, maybe Taylor dropped.
No, I'm here. I missed the question.
That's okay. It wasn't a great question anyway. I was just asking, just at a glance, if it made sense to have it by contract, by language, or by language by contract on the organization.
I mean, that feels a little bit more like a bike shed. I'd probably do with whatever was available. It's not a big deal to me. I just make sure it just follows whatever pattern you choose. Otherwise, it just feels very much like a bike shed.
Hey, Liam, go back in the repo if you don't mind.
Yeah, sure.
So go under like key value. I can't remember which ones I stubbed out, but go under Rust.
All right.
And then click codegen.yaml. The main rationale for this is, see where it says schema ... right? Is that all the languages can go down directory, and they all reference the same WDL file. So the WDL files aren't copied and pasted all over the place. I think that was the way it was kind of working before. But yeah, so they're all working off the same sheet of music, basically. Whenever you run your make to do the whole kit and caboodle, there's less duplication of the WDLs.
Yeah, that makes even more sense, Bill, to have it, you know, one WDL file, and then, you know, the everything else derived from that.
The WDLs haven't been duplicated for months. They're all now in the schemas directory. But yeah, it's a little bit of bike shedding, but we should get this cleaned up before we're done releasing.
Okay. All right. What about on Wash, Brooks? You know, anything that's blocking you, or you're waiting on some help with here?
Not for Wash. Same. You know, there's like 2 easy punt issues in here. One of them is going to be resolved by just bumping the provider archive version. We had a new version of the N keys and the wascap crate go out this past week, so just need to bump that in Wash too. I think the biggest thing that's still outstanding is removing the Git dependencies from our cargo list. So making sure that, you know, we need to publish wasmCloud host, we need to publish the control interface, and when Krustlet releases, we can pin to a version of OCI distribution, which is one of the crates that's in the main Krustlet repo. Mm-hmm. So we're sitting at a pretty good point. Most issues that are coming in now, I'm pinning to the 0.3.0 milestone, which is just, it's a generic way to say that we're doing it after the 0.15 release. So anything in there with 0.2.0 is planned to be completed with wasmCloud 0.15.
Okay. All right. So not a lot left here on the punch list to get that out. Yeah. And so Krustlet, all right, you guys going there, and you know, in theory, you know, we're, you know, 4 days away from like our release goal of 31st, and I still owe the form for the release party, and of course, all are welcome to that. We'll get together and play with our little snow globes. together on a call sometime. Anything else? Just open call. Kevin, Gustav, Chris, anybody want to raise any issues or concerns, or anyone on the call? Okay, well, I think that wraps us up for the week. I'm going to go ahead and stop recording, and everyone's welcome to hang out. We can chit chat and talk for a little bit. Actually, one thing before we go is demos for next week. We've got as on our to-do list, Whittle, Bindle, maybe looking at the new website if we're done, or packaging, Kata Code tutorials, Krustlet, Wasm 3 on small devices, Yeoman. Anybody want to volunteer for next week?
When you're talking about Yeoman, are you talking about the thing that we've been working on with the generator for stuff?
Yeah.
I mean, ideally, so Ivan on our team would be the best at probably presenting that, but he's in New Zealand time, and so it's honestly not convenient for him, I think, until at least after like 1 p.m. Central Tech time, I mean Pacific time. So that's just something to keep in mind, that that'd be the easiest. One of us can probably demo it, but we can do that. And then Bindle will be good too. We're actually working through how signing of bindles and everything will work. So it'll be probably a good time for you to try it once we cut Bindle 0.3 out. But that's chugging along too.
Okay. All right. That's phenomenal. Well, I'll coordinate with you a little bit offline on those, and I'm going to go ahead and stop recording.